Computers keep changing. Okay. Oh, man. I am leaving this far too late. Later and later and later. It seems like, in fact, the cable network may, in fact, be back up at the moment, but I already committed pretty much to trying this 5G hack, so I'm expecting it's going to be bandwidth starved in various places, but we'll see. I did a few little tests. Some of you folks looked at them, and it seemed like it worked, so we shall see. Hi folks, it's T2sday update. I am Dave Ackley. I'm a retired computer science professor, and I was learning from reading Mr. Beast's production guidelines that the whole point is to make the title card, be justified, and you need to justify the title card in the first minute before people all click away. And of course, we get very tiny audiences here, but that's fine because this is esoteric stuff. But I figured the only thing that I could really do, that I could really say, is that this is not spending money. This is not goofy. This is research, and I kind of act like a professor. I still do. So I'm going to try leaning into that and see if the clickbaitiness of a professor giving a live class, is perhaps more compelling. So here's our title card for today. Or something like that. So we'll see how it goes. The T2 Tile project is about building this new kind of computer. Everything's distributed. It's like a cellular automata on acid, as was described for some other folks' stuff, but similar to this sort of thing. And what we've been doing for the last several months, many months now, is connecting this cellular automata, this big distributed spatial computer, to a simulated robot called BV. And so we've got a little bit of a BV adventure to watch, and then we'll keep talking. One day, BV and Seneca, the summer intern, were just knocking around having fun. They were working on a bouncing problem where, after backing away from red, sometimes BV just barged right back into it and then had to back away again. Seneca said, "What if you had like a timer so you could stay and avoid red a little longer before going blue?" "Okay," said BV. "I like having stuff. What's a timer?" Seneca had to think about that for a minute. "Well, you react to things, right? Dread the red, follow the yellow." "Right," said BV. "I see I do." "Well, a timer is a way to do something even after the thing you saw is gone," said Seneca. "That sounds crazy," said BV. "Should I be reacting to something that isn't here right now?" BV looked suspicious. "If you had a timer and it just went off, yes, exactly," said Seneca. "I don't know," said BV. "I mean, if I could just keep an eye on the darn red, everything would be great." "Hey," said Seneca, "that's a really good idea." "Thanks," said BV. "What is?" But Seneca was off modding BV's brain and muttering about feedback. And before you know it, BV had a new brain and was approaching red again. "Whoa, this is great," said BV. "What did you do?" Seneca said, "I wired your red sensor to your eye stalk position so that as you back away, you'll keep an eye on the red, just like you suggested." "Wow," said BV. "Cool." That was a good day. So yeah, that was a lot of fun, actually. So the basic idea is The BV's eye stalks are controllable, and so you take the amount of red that you're seeing on one eye or the other eye, and you connect it to the eye position swing, so that when it sees red, it pivots the eye further out to look more sideways. And when it doesn't see red, it pivots back towards a more, it's sort of like a predator versus a prey eye positioning. And red is the predator for BV. So it has this nice effect, which you saw in the episode, that once BV gets caught by the red, its eye keeps looking. Even as BV is turning away, the eye is still looking back until finally it snaps and then goes forward, and it gets very nice. And, this whole idea of, there's this continuous process of thinking, I have to use sequential computing, like Seneca was thinking, let's use a timer, let's use an internal timer so that when the blue runs out, you keep looking red anyway. And you could do that. And in what we're going to see later, there's a bunch of timers. But this particular case, BV spinning further away, driving that point in, by continuing to try to keep an eye on the red. So natural. And it came basically for free. All the signals were there. You just had to route them in a few new places with a minus sign and whatever. You saw magic numbers that got tried out. So that was a lot of fun. And okay, so overall, for today, the goals were we've got Lou Wilson, Toad Pond, and I have a talk to go with this paper. The paper got accepted. We got to do the talk. We were supposed to have done some talk development. Lou has been a little busy. So do we need a little bit more light here? Maybe. So that's coming in a bit of a rush now, because the talk is going to have happened before the next T2sday update, before class is in session again. And BV localizes itself. Well, that's what we're going to see. Made some progress towards it. Made definite progress for it by using this idea of when do you really need sequential computing, and what does that mean in the context of spatially distributed cellular automata, these crazy ways of doing it. And Bigger Fun, had a lot of fun this month. It was good. All right. So development first. The BV, so I already talked about the development point. Excuse me. That, there's been all kinds of little hacks going on, little improvements. BV, for example, when BV is pursuing a yellow ball, it tended to go very, very slowly. It was like Elmer Fudd saying, I'm killing a hunting rabbit. And it would take forever. And that's just a consequence of the Breitenberg vehicle concept, that you take a signal level and essentially you connect it directly to a motor level in the simple view. And so that means it's linear. So if there's a tremendous amount of signal, you go really fast. And if there's very little signal, you go really slow. And that may not actually be what you want. So now, for example, BV has a more complex transfer function for how much yellow it sees to how much motor values it should go. It makes it go a little bit faster and so on. There's tons of that stuff that happens every month that I haven't talked about. I wish I could share it all with you, because, it all sort of seems cosmically interesting to me as I try to understand what bottom-up engineering really feels like, how it's so different than deterministic execution, top-down, traditional programming, traditional computational models. Making these examples of working bottom up and trying to build BV and trying to figure out how to do things in a way that, maybe fits into the natural structure of the architecture that we're building is the purpose of doing it. It's the purpose of the sixth day of Robust, is learn by implementing. And that's what we're doing. We're learning by implementing this stuff, trying to cheat as little as possible. So it's not about making it the coolest looking thing as possible. It's not about making it run really fast, although it sure could use a speed up. This stuff all runs so slowly that we're seeing it in time lapse. So be it. So, essential sequential computing. So the basic idea, I'm going to try to take maybe 4 minutes here, something like that, until like 12 minutes after, something like that. We'll see how it goes. With cellular automata, your computation is distributed in space, and so it's very natural as far as doing parallel computation, where all these different locations in space are doing their little things at essentially the same time, or literally the same time, depending on the model. And so, unlike the CPU and RAM model that all it can be is sequential. It does one tiny little thing each time, but it does it so freaking fast. So the idea is, with a distributed parallel computer like a cellular automata, you could read in potential all of those locations at any given moment. You could sense or compute or detect something, whatever it is you want to do, spread out. And you could compute some transfer function that's a function of how much you can see. So if you could see 3 different variables, then you could have like a third order function that you were computing at this one little spot. But if you wanted to have a much higher order function, if you wanted to take into consideration thousands of variables, then you can't do that in little things, because in a cellular automata, each little processor cell unit can only see a tiny little bit. So you have to merge stuff together. You have to say, okay, I'm looking for this thing. I didn't see it. Did you see it? No. Did he see it? No. And so on. So gradually you build up a higher order computation out of these low order pieces. And sequential computing is great for that, because it keeps doing the new operations with potentially new inputs that came from here, came from there, in the same place. So at first you just get little local information, but you've got farther out information on its way to you, on its way to the sequential processor. And when it gets there, you now, in effect, I did some steps on this stuff, and then I did steps on this and this and this and this and this. And so, in effect, I've computed a function that's the sum of all those different dimensions of the various things that I pulled together and computed with. So, sequence does multiple things in the same place. Now, a lot of times I say that's bad, because that means we have to erase our previous results. When we do the next step in the same place, the CPU, or just one of these little processing units, whatever, then we erase what used to be there, unless we took deliberate action to store it someplace. Whereas a distributed cellular automata in space, all of the stuff that's doing transformations is still there. So if something goes wrong, it's much easier to recover it. And so sequential computing is fragile, because it keeps throwing away its results and reusing the hardware. But in exchange, it's very powerful, because it can pull all these things from different directions and reuse the same hardware over and over. Now, how does it relate to the sequence and the self-image? I'm just going to say it's the pretty obvious thing for the moment here. We're going to have to don't have enough time to talk about the self-image in detail today, but the self-image has 4 processes: input, output, sequence, and judge. And sequence is the idea of taking step after step after step entirely inside your head. So that nobody from the outside, without using, special detectors or MRI or squids or something, could tell what's going on inside your head. It's internal sequencing versus, doing a bucket brigade or writing notes on pieces of paper and then reading them back what you have. How is BV using sequence? Okay, that's the main point. Let's take a look at this second clip, and actually that's going to use up most of our time, and we're going to end up, have to do it next time. Then one day, BV dropped onto the grid and quickly realized there was something going on. For one thing, lots of bigwigs were in the lab, including both the lead dev and the architect. And on top of that, there were no balls, yellow or blue, on the grid, and there was this green thing that wasn't there before. BV called out to the lead dev, "Hey, I thought the idea was the laws of physics never changed. What's with this new green thing?" "No, that thing was always there," said the lead dev. "Nuh-uh," said BV. "I never saw it before." "Yah-huh," said the dev. "Before now, you just had no green sensors." "Whoa," said BV. "Really? What is it?" It's the green sun, said Seneca, the summer intern, glaring at the lead dev who was standing with a smirk. It turned out the story was the director wanted to know why BV self-localization hadn't made more progress and yelled at the project manager who yelled at the devs who pointed out there was no way to orient on the grid. Everything BV experienced was essentially equivalent in the 4 compass directions.
Oopsie,
and the project manager wanted to know why nobody had noticed that to begin with, and the architect said, oh, we did, and we had a magnetic field and polarized light and terrain, but if you'll recall, the director shot all that down and picked a featureless damn checkerboard in the name of elegance and scientific rigor. Little help, said BV. So the great challenge to use the green sun so BV could orient began. So the great challenge of using the green sun to help BV orient began. And it took a long time. There were a lot of problems. But eventually, it started to work. So that spinning around in place is a key sequential step where BV tries to mark the direction that east is, makes complete circles and counts how many events using sequences it takes to make a complete circle to bring and recenter on east. So yeah, this is BV's new grip, the Orient grip, which I love. I read someplace that Orient used to mean face to the east, and then it split into meaning the east and meaning face in any direction. So that's what BV's doing here. He's using the new not the new green sun, the always been there green sun that BV just never saw before, and using it to navigate around the grid. So step by step. Oops, yeah, there was a little glitch in the matrix there. Okay, so that's it. All right, we're at 12:16, so I'm going to need to move on. So we got two new Living Computation Foundation nerds this month. Thank you very much. Ian, I haven't met, I don't think. Richard is actually my oldest friend, so thank you. And I absolutely over time, so I'm going to let this go. Next time will be November 5th. Class will resume. Class will be in session again November 5th. In the meantime, come visit us on the Discord and so forth. The goal is BV actually localize itself. Try to figure out some representation of where it is on the grid and have lots of fun. And we shall see. Thank you so much for stopping in whenever you came to see it. Hopefully there was some little bit of value in addition to all the everything else. Hope to see you next time. All right. So that is it. Hopefully I turned the microphone on. Okay. All right. Hey, look at all the folks. That looks great. There's lots of little comments from people, and I'll look back at them. Schlabbermouth has got a cat in a box, I guess. Wong Izzy, hi. Lucky to catch on live. Yeah, thanks for stopping in. I don't know if we've met or chit-chatted on the Discord, but thank you so much for coming. Yeah, Cy Speed. BB went into the a lot this time. There was a whole internal reorganization that went on that, again, it's a sort of thing that I would love to talk nerd about, but it's really takes a long time to go into, and I'm really trying to keep these short and high level. I'm not sure why, but is what it is. Right, from Europe into the Orient. So that is it. I mean, I guess, except for the fact that, like I said, I have to, my cellular plan doesn't actually have that much free data, so this little experiment is probably going to cost quite a bit, and the bandwidth is pretty low, so I'm assuming when I move around a lot, it's going to fuzz out and have to figure out what's going on again after the motion kind of slows down. So Kempe, this is still not, well, it depends on how you view it. I was going to say this is still not learning, but it's starting to become a hybrid in the following sense, that the Orient grip, the grip number 4, the 4th grip, it's actually a family of grips because there's Orient to the east, to the south, to the west, to the north. As separate grips, they all do the same thing. They just say, how far should we go? So there is that step when we move into the Orient grip, where first BV stops, then BV starts driving the wheels forward and backwards so that it spins more or less in place, and it waits until it sees no green, and then waits until it sees the maximum amount of green and takes a note of how much green that is, the sum of the left and right sensors. And then it goes around down to 0 and then back up to that max again, or 90% of that max. And it counts how many events it took to get from green, max green, back around to max green again. And then it says, okay, well, if I wanted to go south, I should go a quarter of that count, because the entire count took me all the way east to east. So if I want to go south, I'll continue for a quarter of it and then stop, and then I'll accelerate out. And that's the scheme. If I want to go west, I'll do a half of what it took, the whole thing. And we couldn't really see because it was complex in when, of course, it was going way too fast. But a lot of those flying into the voids were connected to attempts to orient that were not working well at all. See, now it looks like I'm buffering, which is sad. And why it says excellent connection and then buffering, I don't know. I guess I'm not supposed to have fun with my hands here. Anyway, so the time it takes to go around, it basically has to turn around like 3 times or 4 times, depending on exactly how it starts. The count varies significantly. The maximum green varies. I mean, the sun is supposed to be the same size no matter where you look at it on our planet, but the lab is not that big. So, in fact, when you look east from the far west on the grid, the green sun is actually smaller, and therefore the max that you see is smaller, and so forth. So it's really important that it actually does self-calibrate every time it goes into orientation. It curls around like a dog deciding how to sit down, or a cat deciding how they want to sit down, and it's beautiful. By driving the wheels in opposite directions, it spins around, and it makes, by making a loop, it can infer how much progress it's making. And, as I change the position of the brains and move stuff around, the number of events that it would typically take to make a full green to full green revolution changed. But since it was self-calibrating, it was self-stabilizing, it didn't matter. So in that sense, there was a little bit of learning going on, just in the self-stabilization, calibration kind of sense. There is nothing yet at the moment that's actually doing what we would more consider traditional learning, machine learning stuff yet. I want to get to it, and I want BV's world model, BV's reconstruction of BV's world, to involve making inferences of the sort of things that a neural net would do. But, all of this stuff is so small compared to, Chat GPT, right? By like a factor of a billion. Chat GPT is like a billion times bigger than the neural net that BV would have inside it. So it's never going to be an obvious machine learning kind of thing like that. But hopefully it'll get to the point where it has a little bit. Pretty 2D neural network before. Yeah, like I said, not yet. My intention, I was hoping originally that we were going to finish off the BB Brain challenge in 2024. I now think it's going to continue into at least Q1 25, and that's fine. I really want to start having bigger and slower areas of computation that's doing higher level stuff, like building a map based on BV's, essentially doing SLAM, essentially doing simultaneous localization and mapping, the super cool algorithm that Andrew Davison is associated with, who talked to us on a Computing Up episode a while ago that was a lot of fun. So that, when you start out, you open your eyes in the world, you don't know what the world looks like and you don't know where you are in it. So you have this chicken and egg problem. Do I figure out where I am or do I figure out what the world is? And SLAM, simultaneous localization and mapping, does them both at the same time. And it's kind of like magic. But what makes it work is that if the world over constrains, you look around, you see things that are not independent views. This view and this view are seeing certain amounts of stuff that's the same. And so you want to be able to figure out, oh, it must be that I was over here looking at a square and now I'm over here looking at the same square. And you can figure out where you are and what the world looks like at the same time. What I would really like to do is see if we could come up with a cellular automata, a distributed, robust first, all of the good words, that does something like SLAM without floating point, without multiply, accumulate, but using some kind of basic associative memory, some sort of sparse associative memories, something like that. And all of that is essentially going to have to get pushed into 25. So we'll see how far that goes. So that's the learning time. Memory and sense of time. Well, memory and sense of time are clearly related. This was a thought that indeed we had mentioned on the Fediverse the other month, that the connection between space and time is motion. Motion is what unifies space and time. And that's, in fact, the same idea about about why I called it the movable feast machine. Because the deep essence is being able to have an object that moves. And that's what the existing cellular automata that we're trying to do, reproducing systems and universal computers and stuff like that, really didn't even ever try to do all of that backwards in high heels. And that's what the movable feast machine, and that's what the digital replicator from 2023 essentially was doing. It was doing reproducing itself while it was on the wing, while its entire set was gradually moving through cellular space. Size, speed, sound, video quality, very consistent during class. Thank you for the feedback. Celestial navigation seems enough. Yeah. Well, I thought at least if I'm going to change the world, between you and me, yes, the green sun was not always there. We did magic, and Seneca was pissed at the dev for not telling BV, for not being honest with BV about that. But as far as we know, she hasn't blown the secret yet. But yeah, BV now BV is very close. Let's say it that way. Is very close to being able to count the checkerboard squares as it rolls over them. It won't be an exact count because when it drifts from, it blows the lane keeping and shifts from one row to another, it'll get some extra transitions that it's going to have to do something with. But again, all of this stuff is sloppy. You look at how the signals that make up the counting that is going around and around, and like some of them go immediately, some of them get delayed for like, multiple updates, and then they go through. And all of this is predicated on the idea that if you have a lower level that's going enough faster than the level that you're focusing on, the causal level that you have in the middle, that this lower level stuff, even though it's got all this kind of variations, those will average out well enough with a small enough variance that we can actually end up saying, okay, it took me 220 events to go 360 degrees, so I'm going to go 110 events and hope that that'll take me 180 degrees. And it's not 180 degrees exactly, but it's not that far off. And then given that what we already had, which BV now has the ability to check the passing squares, the checkerboard squares, and correct its heading a little bit to get straighter on, so that basically the orientation just sort of needs to get like between, plus or minus 20 degrees of the correct heading or something like that. And then BV can accelerate out of orientation and gradually trim itself to get a better straight line. And that's what happens. That happens every time. You can see that happening in the successful run. Again, it's just going faster and faster and faster. So that's it. Thanks so much, folks, for coming, and especially for folks who interact and ask questions or make comments, because, it gives me something to talk about here when I'm not worrying about, trying to be broadly accessible and so on and so forth. We get nerd out hard now, like that. So, okay. Should we call it? Considering how messed up today was, it seems like we did okay. All right. Well, so again, for you live viewers, thank you so much. I can't even exactly express. Let me finish the sentence. I can't even exactly express why it's so important to me that I do these updates live. And I know it's a whole bunch of things, but a lot of it is the teacher mode, the teacher instinct, where, for all of the things that teachers tend to do badly. I'm sure you've had good teachers in your life. Well, I hope you've had good teachers in your life. I'm sure you've had bad teachers in your life. For all the things that teachers do badly, just to be able to show up and rap. It's like we have a presidential candidate who that's all they can do, and it's predicated on just making stuff up. And the guy is very, very proud of himself that he can just keep it going, blah, 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 like that. Well, every teacher does that every day. And hopefully they do it with a certain amount of truth, a certain amount of useful information, rather than just flapping. But it varies. I've had bad teachers too. Okay. Well, thank you guys, and whoever, for being here and for interacting a little bit. And I hope I'll see you all next time. All right. Thanks, everybody. Ending the stream. Half hour. That seems right. Okay. Here we go.